Alright, just doing a quick little test on my amplifier. So this is the bias voltage. Here is the power supply going to the amp. This is a 48 volt amplifier, but it will run anywhere from 15 up, but it only gets used at 48. So if I turn this on, this is my passive draw on the amplifier, exactly 0, because there's nothing that uses power. If I key it, now you can see we got 500 milliamps. That's probably some of the fan as well, and 2.6 volts, 264 on the bias there. I'm going to do the same thing at, let's say, 24 volts. Yes, this is while the amplifier is on. That'll do. 78L05 still works. 24 volts, exactly the same current. Wind her all the way up to 30, it's as far as it goes, 32. We shove her in. 2.645, 550 milliamps. And 32 volts is what the MOSFET sees, so it doesn't matter about the voltage at all. Pretty much all that current is identical. So anyway, the MOSFET's working, I believe, or at least the fan is. I better check that actually. I'll disconnect the fan and see how much bias current I actually get. And maybe I'll adjust the bias to a transconductance curve, and we'll see if that MOSFET, my 5600 HR6, well, I think it's MRFE 6VP 5600 HR6, that one in there, is okay, and it probably is. All right, I'll see you in a second. All right, so we're going to start it off where it was, 32 volts. Actually, you know what? We don't really need 32 volts because that voltage is the same. Let's go down to, I don't know, maybe like 15 volts. It doesn't really matter, it just burns less power on the MOSFET. So there we go, 15 volts is fine. Now I'll get my PTT line. And we will trigger it. Oop. There's MOSFET, so 380 milliamps. I'm going to do a transconductance curve. So this is going to be a while. What I'm going to do is I'm going to get an Excel spreadsheet or something and read that bias voltage there and then note that current. And this is going to take me a while. So maybe I'll make a graph or something and see how linear this MOSFET is. Be right back. Alright, that's the best I can do for now, so let's start measuring. So I've got this as a ground lead that's connected into the power supply. So if I just short out the PTT line, we're now in transmit mode. We see current. This is bias current. Now I'm going to... Meter went to sleep. There we go, there's our bias. I am going to adjust it. If I can get my screwdriver on there, that would be good. There you go, now I can see. Alright, let's come down to so 100 milliamps at 2.378 volts. Let's go. Now I should have the fan on, but I don't really need the stability for that. It's not that critical. We're only dealing with 20 watts of power there. 200 milliamps at 2.54 volts. Oh, hang on, a little bit more. Yeah, 2.546. Let's go 300 milliamps. Oh, if I could get it right, that'd be nice. A little bit funny, this pot. 2.609, 300 milliamps. Yeah, here we go. $400 milliamps at 2.65. 500 milliamps at 2.68.
600 milliamps at 2.71. 700 at 2.73. Come on, go back. 800 at 2.755. 900 at 2.77. There's an amp. Now I'm going to kind of go pretty quickly for these next ones because the current's getting higher. So 1 amp, 2.78. I'm going to immediately go to 2 amps. Or 1.5 amps I'll do. I'll do half amp increments. Oh, I do need to turn the current limit right up. There you go. 1.5 amps at 2.85. 2 amps at 2.9. 2.5 amps at 2.95. 3 amps at 3 volts. 3.5 amps at, come on, 3.02. 4 amps, 3.06. Go to 5 amps now. This is kind of getting a 73 watts, right? 3.11, 6 amps. Remember, this is bias current. Also, there's no temperature compensation. I'm going to stop here, I think. 3.16 volts. Now, I'm going to kind of settle it there. That's 90 watts of power, so I'm going to stop there. 3.16 volts. Now, this MOSFET, if I touch it, is cold, right? This whole thing is got copper there. It's got this much heatsink. And without any temperature compensation whatsoever, look at my current. 6 amps continuous. It will change. You see, it is climbing. See? Milliamp, another milliamp, another 5 milliamps. However, not really worried about this. The reason why I don't adjust bias voltage at all with temperature is because that is the result. And the second that I unkey, it goes down. And remember, we're not biasing at 6 amps. We're biasing at like, I don't know, 200, 300 milliamps, something like that. I might bias it down to 1 amp, so I will actually change that. But this is no fan at all. This is no... I'm just going to wind this back down to 1 amp, let's say. Oh, 1 amp is 50 watts of bias, though. That's quite a lot. It kind of makes me feel a little bit uncomfortable. Now, there you go, there's 1 amp of bias. 15 watts of power, of course, 1 amp. Now, you see, watch this. The MOSFET's cooling down. Because it's no longer doing 6 amps. So, yeah. This is why I don't bother with temperature bias. This is my real true amplifier. That chip there probably cost more than this thing's worth, that's for sure. You can't really buy them anymore, but you can buy replacements, like the Art 600 or whatever it is. MRFX 600 is no longer affordable. Also, normally we don't run 15 volts. I'm going to just do the same thing and wind it up to 32 volts. Yeah, 33 watts of power. Sure, there's more power getting burnt. Oh yeah, climbing a little bit, but you see how that basically didn't change? And the second that I put this fan back on, oops, there goes a piece of tape or something. There we go. Sure. It's cold as. Anyway, this amplifier, or at least the biasing, the MOSFET tests okay. So I don't believe my issue is the amplifier. I'm getting some weird audio issues, so I don't think it's this. Rightio, that's all I have for you. Catch you later, and MOSFET amplifiers, pretty fun, right? And just for fun and games. That there. If I can see it properly, that'd be nice. Now let's focus on it. That right there, that is on right now, that there is the MOSFET, and I'll put my finger next to it. You can see it's about 3 fingernails wide, or 2 fingernails wide for 600 watts, in theory. I don't run it at that, of course. Can barely get, well, basically I can get 400 out of it with this contraption. I have dual, what do I have? Dual 4-to-1s, so that makes a 9-to-1 match. And then I've got inductor feeds. So, where is my inductor feeds? No, I don't. I have the split transformer in the middle. That'll be type 61. Yeah, type 61 split transformer in the middle, feeding the drains. And these 4-to-1s are doing the impedance matching. And of course, there's a little bit of power supply decoupling and these capacitors, chunks capacitors. If I could focus, that would be good. But oh well, can't always get what we want. Of course, it's got some filtering. That's the 5-pole filter. It's got my pure signal sampler. That's pure signal right there. That's all they are. Just a little toroid with a couple of windings. There's my SWR bridge. I don't know why this phone refuses to focus, but maybe we can zoom in. Yeah, there we go. Hey, some focus. Look at that. Here's my SWR bridge. I'll just show you the pure signal again. Of course, that T's over to this T, which reduces the signal down to what I need. It's a bit how you're going, but so is the rest of the amplifier. It's 12 volt. Hang on. No, the 12 volt rail's over here. There's a little MOSFET with a Zener diode that turns it off. So it's not very 12 volts, but it's 12 volts enough. This here is the fan switch. So pulls in the fan on PTT, which is why it's over near the PTT side, and there's a memory for protection. So those 3 diodes are capable of turning this amplifier off. And RX-TX relay, which is just a regular relay. Anyway, isn't she a beauty? Alright, 730 VK4 Delta Lima.